Today's practical is on thermal insulation, which is one of the required practicals for physics. There are two parts to this practical. In the first part, we will be investigating the effectiveness of different materials as thermal insulators by measuring the temperature change in hot water in insulated containers. Now, for this practical, we will need some hot water, which I have boiled in a kettle, a stopwatch, a thermometer, a circular piece of cardboard with a hole, and 4 containers insulated with different materials. Now I am using cans, and the first one here has been insulated with tin foil, another one with paper, another one here with bubble wrap, and then a can with no insulation. So the independent variable for this practical is the insulation, the dependent variable is the temperature, and the control variables are the initial temperature of the water, the size of the containers, the volume of water used, and the time scale for measurement. So first of all, I will start the practical by using the container which has been insulated with tin foil. Now I have also insulated the bottom of the can to reduce heat loss from the bottom. So we need to now pour in 80 centimeter cubes of hot water into the container. And then place the lid on top of the can. Now, for improvement in accuracy, we can use a lid which has been wrapped in the same material as the can. So I have wrapped one here in tin foil. We shall now pierce the thermometer through the hole and place the lid on top of the can. The lid should fit nicely on the top. And push the thermometer down so that the bulb of the thermometer is in the hot water. We need to now take the initial temperature, and for accuracy it's best if we read the temperature at eye level. So that measures 82 degrees Celsius. This is our temperature at 0 time. We need to then measure the temperature of the water every 3 minutes for a duration of 15 minutes. Now, hot water in the container will cool down at different rates depending upon how the container has been insulated. And water cools down due to conduction and convection, and heat is lost from the container at different rates. So I shall now start the stopwatch and take the measurements every 3 minutes. In part 2 of the practical, we will be investigating how thickness of a material affects its thermal properties by measuring the change in temperature in hot water when the containers have been insulated with different numbers of layers. So the hypothesis for this is that as you increase the number of layers, the rate of cooling will decrease. So for this part, we need the same equipment. And again, I will start off by using the container which has been insulated with tin foil. So I need to first increase the number of layers on the container. We will be measuring the temperature change when the container has been insulated with 0, 2, 4 and 6 layers. So to start off with, we can use the results for 0 layers from the experiment we did on the can which had no insulation, and then move on to the next step, which is the 2 layers. Now this can already has 1 layer, and I have here a piece of foil which has been cut to size so that it goes round the can once. I shall now wrap the piece of foil around the can, also wrapping it underneath as well. And we can hold the foil in place with some sellotape. Put it down so it's nice and tight. And then again, we need to add in 80 centimeter cubes of water. And place thermometer through the hole in the lid which was insulated in the tin foil. And we need to take the initial temperature and then take the temperature of the hot water again every 3 minutes for a duration of 15 minutes. We can then repeat the practical with the remaining containers. And we need to increase the number of layers of the paper and the bubble wrap. Our results show that the temperature change is the smallest where paper was used, indicating that this is the best insulator out of all the materials we tested, because it has a low thermal conductivity. The temperature drop was the greatest where tin foil was used, so this is the poorest insulator. We can plot cooling curves for each insulator all on the same graph, with the time on the x-axis and the temperature on the y-axis. You can see from the curves that there was a rapid drop in the temperature where no insulation was used, and a slow temperature decreased where paper was used. The results show that with 2 layers of tin foil, the temperature change was 24 degrees Celsius, and with using 6 layers, the temperature change was 20 degrees Celsius. This indicates that there is a smaller decrease in temperature with increased layers. Our results support our hypothesis. We can use our results to plot cooling curves for the different numbers of layers of insulation, all on the same graph, with time on the x-axis and temperature on the y-axis. You can see from this graph that the temperature decreases faster with 0 layers of insulation compared to 6 layers. So increasing layers reduces heat loss.